the first question says, write 19.407 correct to 3 significant figures. So we count 1, 2, 3, 4, 5 significant figures in this number. So our line has to go to the right of the third significant figure, which is right here. The third significant figure is a 4. We look at the 0, which is the fourth significant figure. It's less than 5, so we're going to drop this here. So our answer would be approximately equal to 19.4. That's our answer there. Number 2, write 0.005483 correct to 2 significant figures. So the first significant figure here is not 0. The first significant figure is a 5. So we want it correct to 2 significant figures. So the second significant figure would be the 4. So our line would come right here between the 4 and the 8. We look at the 8. The 8 is greater than 5. So we add 1 to the 4. So our answer would be approximately equal to 0.0055. Let us continue. Number 3. State 9,862 correct to 1 significant figure. So we're going to draw a line immediately to the right of the first significant figure, which is to the right of the 9. Okay, the 8 is greater than 5, so we have to add 1 to the 9. 9 plus 1 is 10, so we get approximately equal to, we write down the 10, and then all the digits to the right of that line we have to convert them to zeros. So 1, 2, 3 zeros. Okay, so you convert the 8 to 0, the 6 to 0, and the 2 to 0, and you do not drop them because they do not come to the right of a decimal point. They are part of the whole number, so you convert them to 0. So our answer would be approximately equal to 10,000. Number 3 says calculate the exact value of 5 3/4 divided by 1 5/9, subtract the square of 1 1/5, and then it says write your answer correct to 2 significant figures. So we want to get the exact value for the expression there first. So we say open bracket 5 3/4. Okay, 5 3/4 divided by 1 5/9, subtract 1 and 1/5, close bracket, and then we go square that. So the answer we get is 2.256428, and then so that's the exact value, and we want to write that correct to 2 significant figures. So we have this here. This is our first significant figure. This is the second significant figure. So the line comes here. We look at the 5, which is the third significant figure. It's 5. So we have to add 1 to the 2. So our answer would be approximately equal to 2.3, because we have to drop all this here, and we drop them because they are located to the right of the decimal point. Okay, so our answer is approximately equal to 2.3. The next question says state the value of 12.07 divided by 0.00897, giving your answer correct to 3 significant figures. Okay, so we have 12.07 divided by 0.00897. When we divide this, we get 1,345.5964. So that's 1,000, okay, 345.5964. Okay, and there are some other digits, but for the sake of answering this question, we're not gonna write them down because we only need 3 significant figures. Okay, so the first significant figure here is the 1, right? So we have 1, 2, 3, 4. So we're gonna put our line to the immediate right of the third significant figure. That's right there. And then we're gonna look at the fourth significant figure. It is 5, and 5, well, it's 5, so we have to add 1 to the 4. So we would get approximately equal to 1,300, right? We have to add 1 to the 4, so it becomes 5, and then the 5 here, since this 5 here is part of the whole number part of the decimal, we have to convert it to a 0. We cannot drop it, so we must convert it to a 0. Everything else that we have to drop, because the digits to the right of the decimal points, right, we have to drop them, because if we convert them to zeros, then they would be significant. Because remember, when you're counting significant figures in a decimal number, a number with a decimal point, even the very last digit, the very last zero is significant. So we don't want a decimal. We can't even keep the decimal point, because if we put a decimal point there, then this zero here would become significant. Okay, so we cannot put that point there. We just have to put 1350, so that this zero here becomes a trailing zero, and trailing zeros of whole numbers are not significant. So our answer is approximately equal to 1350, and that's three significant figures: 1, 2, 3.